So let's say that somebody came up to me and they were like, you know what? You need to draw the formula for sodium carbonate. I'm like, all right, I got my polyatomic ions table and I got my periodic table. I can do this. So first thing, I have to find sodium and carbonate and their charges. So sodium, the symbol is Na. I know that sodium is in group 1, therefore it's going to lose an electron when it reacts, so it's going to have a charge of +1. So it's going to be Na+. And then I know that carbonate, I can find it on my polyatomic ions list, and it is a CO3 2-. So now I'm figuring out my charges because this needs to be balanced. It needs to be a neutral whole molecule. So if I know that my Na has a +1 charge, but I have a 2- charge here, I need to balance out this charge. So if I have 1 + 1, I have to have another one, Na+. So +1 + 2 balances out -2. +1 + 2 balances out -2. So my final formula is going to be Na2. And then I'm going to put my polyatomic ions always in parentheses. They always have to be together. Boom. So now my 2 +1 sodium ions will counteract this 2- charge, and I don't have to add any more of these balanced out. And that is the formula for sodium carbonate. So now let's do another example. Let's say that somebody comes up to me and they're like, hey, you got to write the formula for magnesium chlorate. So I'm going to say, not a problem. I got my periodic table. Magnesium is in group 2. So when it loses electrons, it is going to be a +2 charge. So these are always +1 charges. These are always +2 charges. These are always +3 charges. These are always -3, -2, -1. Oh, -1. It's a pattern. Okay. So magnesium is in my +2. So I know that my magnesium, symbol Mg, is a 2+. And I know that chlorate, you can look at my chart here, chlorate is a ClO3-. So ClO3-. I have to figure out a way where the charges of these two, when I combine them, are balanced equal to 0. So if I have 2+ here and a -1, I'm going to need another -1 to balance out this 2 positive charge. So I'm going to need to draw another one of these. So 2+, -1, -1, -1, -2, 2+. So 2 of these will counteract this 2 positive charge. So my final formula is going to be Mg, and that's 1 only. I'm going to put my polyatomic ion in parentheses, and I need 2 of them, so I'm going to do a little 2 subscript. All right, so let's step it up a notch here. Let's say that somebody comes up to me. I don't know who is coming up to me and telling me to do all these things, but they come up to me and they're like, hey, draw the formula for ammonium phosphate. Well, ammonium is NH4+, and phosphate is actually all the way at the bottom here with PO4 3-. So I need to come up with the formula that balances out these charges. So I have 3 negative. This is my largest different charge, and I have +1. I know that I can add 2 more of these molecules to balance out this 3 negative. So if I draw another NH4 positive and another NH4 positive, I have a +1, +2, +3 charge and a 3- charge. +3 -3 add up to 0. So my final formula is going to be, keep my polyatomic ion in a parentheses, NH4 parentheses, and I have 1, 2, 3, so a subscript of 3. And then I only have 1 of these. I'm also still going to write it in a parentheses, When there's only one polyatomic ion, you don't need to put it in parentheses, but let's just make it a rule where every single time you are going to draw parentheses for polyatomic ions. So I got 3 ammoniums, 1 phosphate ion, and when you put those together, the charge of this whole thing becomes 0. And that is how you draw your formulas or write your formulas based on the name.